Greetings to every one of you. So in this video we are going to discuss how to represent the graphs using adjacency matrices. A adjacency matrix can be defined as for a graph G of V comma E where V represent number of vertices and E represent number of edges can be represented using a two-dimensional array of size n cross n. That is, a graph can be represented using a square matrix called adjacency matrix. So now we are going to discuss how to represent adjacency matrix for undirected graph, adjacency matrix for directed graph and adjacency matrix for weighted graph. Let us see first one, adjacency matrix for undirected graph. Adjacency matrix, that is Aij, is equal to 1 if the vertices Ij are connected by an edge. Otherwise, this Aij is equal to 0. We are going to use this binary representation, binary values, if the connection exists, that is indicated by the binary value 1. If there is no connection between the vertices, that is indicated by 0. So adjacency matrix of an undirected graph is always symmetric. That means an edge Aij is always equal to edge j comma I. Now let us see how to represent this adjacency matrix for this graph. So we have taken the vertices in number of rows as well as in number of columns. So totally there are 5 vertices and we have taken all these values in the rows as well as in the column. Now we are going to check the connectivity. So whether A is having any self connection. If there is no self connection, that is 0. So A is connected with the vertices, that is B and D. So we have the direct connection from A to B and D only. So B and D indicated as 1 and remaining this other values, that is connection from A to C, there is no connection, connection A to E, there is no connection. So those values, those positions should be indicated by 0. Similarly, take B, there is no self connection. So B to B, there is no connection. Now, so B to A, B to C and B to E. So B to A is 1 and B to C it is also 1, B to E is also 1. So the remaining values are 0. Come to C. As far as C is concerned, C to A, that is 0, then C to B 1, C to D 1, C to C 1 and C to E, that is also 1. Okay. Similarly, come to D. So D is having connection only with A and C. So A and C. So remaining other positions are 0. Similarly, take E. E is connected with B and C. B and C. The remaining positions are 0. If there is a connection, the connection is indicated by binary 1. If there is no connection, that is indicated by binary 0. The number 2, adjacency matrix representation of directed graph. So if you take this node A, vertex A, it is having connection with A to, that is B, A to C, A to D. So A to A, that is 0, A to B, that is 1, A to C 1, A to D is also 1. There is no direct connection from A to E, so that is 0. Similarly, come to B. So there is no connection from B to any other node, so all the values are 0 because there is no edge from B to any other node. Okay. Come to C, that is from C to we have C, there is a connection, that is self connection, self looping, and C to E is also present, but remaining other values are 0. So we will come to D. From D there is only one connection, D to E, D to C, there is only one connection. So remaining other values are 0. Similarly, come to E. From E you have only connection to B. There is no connection from E to any other node. So remaining values are 0. So this is how we can represent adjacency matrix for the directed graph. So as for the adjacency matrix of directed graphs, never be symmetric matrix, because the edge I comma j, it is not equal to edge j comma I, because if you take the A to B and there is no the value from, there is no connection from B to A. The third one is adjacency matrix representation of weighted graph. See, here the weights are nothing but the values which are assigned for each edge. This may be a distance from this node to this node, or we can say that it is a cost to reach this node from this node. Okay. So now see that A to B we have a value that is 10, A to B 10, A to A there is no value, there is no self looping, so that it is 0. Then A to C we have a value that is 70, then A to D it is 50. There is no connection from A to E, so that is 0. Similarly, come to B, B to A that is 10, B to C that is 60, B to B there is no connection, 0, then B to D there is no direct connection, 0, B to E that is 20. Similarly, come to C, C to B, C to A that is 70, C to B that is 60, we have C to C connection, C to C it is 35, and C to D is 40, and C to E is 30. So this particular node it has a connection with all the other nodes. Similarly, come to D. So D to A it is 50, D to C it is 40. Then there is no other connection from D. So D to C, D to D and D to E all are 0. Similarly, come to E. From E to B you have connection and C you have connection. So E to B it is 20, E to C it is 30, E to A and E to D, then E to E all are 0. So this is how we can represent the adjacency matrix of the graphs. So the graphs can be represented using the adjacency matrix. So in this video we have discussed what is adjacency matrix. So how to represent the adjacency matrix for the undirected graph, directed graph and the weighted graph. I hope you understood the concept. Thank you. Keep watching.